It's official. Atlas does not conform to the standard cometary model. Listen closely, everyone. Scientific validation is here. Recent measurements and observations converge towards a stark and disconcerting conclusion: Atlas is not a comet. A wealth of evidence comprising Hubble images, JUICE, probe data, spectra, X-ray detections, composition studies, and ground observations from amateur astronomers collectively dismantles the traditional comet theory, piece by piece. This isn't mere speculation. It's a substantial body of evidence that necessitates immediate reclassification. Let's cut to the chase. If you anticipated the usual characteristics, dust ice, a dense coma, and diffuse jets, you should prepare for the contrary. Atlas exhibits self-generated energy emission, a rigid forward jet, an unusual metallic composition with excessive nickel, unprecedented optical polarization, acceleration defying gravity alone, and a shape reminiscent of engineered objects. Yes, these assertions are robust, but science operates on evidence rather than dramatization. Currently, all the evidence aligns towards the same conclusion. What's new in this narrative? Recently acquired images and data have transformed our understanding. In just a few weeks, we received pivotal images and measurements. The JUICE probe captured the object, utilizing its navigation camera and scientific instruments during its approach in early November 2025. Hubble revisited Atlas on November 30th, providing a post-perihelion image that depicted a drop-shaped coma and an anti-tail, extending toward our solar system's central star. Avi Lobo scrutinized these images, noting that the anti-solar extension perfectly correlates with a predicted detachment of a swarm of objects from the nucleus mapped at a separation of about 60,000 km in parallel. Images captured from ground-based observers in Namibia and elsewhere showcased distinctive jets, including a forward-projecting jet exhibiting notable coloration. Conversely, processed editions of the Hubble images reveal artifacts resembling a square outline near the nucleus in recently published frames, casting doubt on the image handling. Nonetheless, even when setting aside processing uncertainties, a consistent observational pattern emerges. Atlas does not operate like a traditional icy comet. Physical evidence undercuts the comet hypothesis. Here's a compilation of physical mismatches that collectively undermine the comet explanation. Self-emitted, a rigid forward jet, an anti-tail aligned with the star, feeble coma and tail, a scarcity of visible material, an anomalous metallic composition, an excessively high nickel-to-iron ratio, pronounced negative optical polarization, non-gravitational acceleration lacking sufficient visible debris, minimal mass loss, inconsistent with extensive jets, rotational signals and elongation that contradict a fractured icy nucleus, repeated orbital coincidences with Mars, Venus, and Jupiter, fluctuating brightness and bluish tint. The jets are columnated over millions of kilometers, and the energy requirements do not match what one would expect from a nucleus of Atlas's size. First point, X-ray detection at Atlas's coordinates is significant. These X-rays aren't just light reflecting from the solar star. They are indicative of self-generated energy emission. For a comet to consistently emit X-rays, it would need to expel vast amounts of gas that, upon interacting with stellar winds and charged particles, would produce such radiation exactly contrary to Atlas, which appears remarkably dry and minimally active. Second point, composition. Research indicates that the observed metallic fraction shows a nickel-to-iron ratio nearing 10:1, more akin to industrial alloys than a typical comet's nucleus, characterized primarily by volatiles and refractory grains in vastly different proportions. This chemical signature raises many red flags. Third point, morphology. The sharply defined anti-tail projecting forward, along with columnated jets and a rigid frontal structure, does not align with the model of diffuse volatile material ejection. Natural jets typically disperse and exhibit comparable colors and compositions from the same source. Instead, in the case of Atlas, we observe jets with varying hues, suggesting heterogeneity that's difficult to reconcile with a uniform icy nucleus. Fourth point, measurements indicate non-gravitational acceleration, showing velocity shifts that gravity alone can't account for. In conventional comet models, such accelerations derive from volatile sublimation, creating thrustbut that presumes mass loss and a visible debris cloud. For Atlas, acceleration occurs without enough visible mass to justify such magnitude. Fifth point, the energy involved. Jets that are both extensive and columnated would necessitate mass fluxes in an area significantly beyond what an icy nucleus the size of Atlas could sustain. Simply put, the observed material and ejection velocities would demand energy sources or propulsion methods that clash with standard comet physics. The definitive evidence comprises an accumulation of anomalies. A single isolated anomaly might lend itself to alternative explanations. However, as these anomalies mount, excess nickel, forward jets, negative polarization, unexplained acceleration, atypical brightness variations, and orbital coincidences, the overall picture shifts. The probability that all of this can be neatly explained by ordinary natural causes diminishes dramatically. The convergence of these signals constitutes scientific validation. Those cautious scientists who first dismissed radical hypotheses are beginning to concede that the most plausible explanation can no longer be simply categorized as a comet. It reflects a rational response to empirical observations. Now, consider the mini-probe hypothesis, a scenario that reconciles these anomalies. Among various proposed hypotheses, one stands out with its ability to integrate the different anomalies, the release of multiple objects, such as mini-probes, scouts, or reflectors, from a primary entity. Modeling and calculations suggest that a swarm of non-volatile macroscopic structures, released near perihelion, could produce the observed antisolar luminous trail. A series of reflectors can align to present a continuous streak from a distance. Here's how this theory aligns with the data. A set of reflectors creates the anti-tail pointing toward the solar star. Lighter objects respond differently to the star's gravity, accounting for the detected non-gravitational acceleration. The multitude of probes and reflectors also naturally elucidates the columnated jets and differentiating color tones of the expelled structures. If part of the material consists of a nickel-rich metallic alloy, this addresses the unusual spectral signatures as well. Moreover, this hypothesis generates testable predictions, a foundational requisite for science. If the anti-tail correlates with the release of many probes, its visibility should fluctuate in conjunction with scheduled delivery events. Observers modeled a significant decrease in visibility around December 19, 2025, coinciding with the conclusion of a delivery to Mars, followed by an uptick near Jupiter's predicted encounter on March 16, 2026, which would bolster the hypothesis. These are clear, observable predictions on in motion. What did Avi Lobo contribute to this investigation? Analyzing the images and initial data, he proposed an interpretation that harmonizes with the swarm object concept. He emphasized that the drop-shaped coma in post-perihelion images aligns with the predicted distance between Atlas and a cluster of larger 60 kilometers, matching the length of the antitail observed on November 30, 2025, by Hubble. Lobo also referenced the preliminary JUICE image taken on November 2, 2025, which revealed a halo and hints of two tails. These images were captured just before JUICE's closest approach to Atlas, and the instruments aboard promised to provide composition, particle, and spectral data capable of confirming or negating the existence of detached macroscopic material. Now let's evaluate natural alternatives. Exomoon, planetary fragment, depleted comet. Before leapfrogging to bold conclusions, it's essential to explore the natural alternatives considered by the scientific community. Exomoon, a moon displaced from an exoplanet, is theoretically plausible, but requires a survival history of billions of years along with a mechanism for the jet activity observed. The metallic composition and X-ray emissions do not easily correspond to a standard planetary fragment. While a piece of a planet could theoretically exhibit high metal content, the combination of directed jets, X-ray emission, and non-gravitational acceleration, absent a visible cloud, remains unexplained in this scenario. The extremely weak, depleted comet hypothesis was an early favorite, yet the near absence of water, about 4%, along with the extreme polarization, anomalous nickel proportions, and self-emitted energy, increasingly undermine this proposition. In summary, none of the natural alternatives comprehensively explain the array of anomalies. In science, this serves as an impetus to investigate hypotheses previously dismissed without serious scrutiny. Before advancing, let's ensure we have a complete overview of the Atlas anomalies. Here are 12 key anomalies linked to Atlas's set so consistent that together, they simply cannot be classified as a natural comet. 1. A retrograde trajectory aligned with the ecliptic plane, statistically improbable for an interstellar object, which would typically display chaotic angles. 2. Jets directed toward the solar star, resulting in an antitail whose geometry cannot merely be attributed to perspective. 3. An apparent mass incompatible with the history of interstellar visitors, suggesting a body denser than what one would expect of a cometary nucleus. 4. A series of successive passes by Mars, Venus, and Jupiter is highly unlikely without additional influences on the trajectory. 5. An anomalous nickel-rich plume with concentrations far greater than in conventional comets. 6. Gas emissions exhibiting extremely low water content, approximately 4%, that contradict typical comet. Make up. 7. Intensely negative optical polarization, coupled with rare phototropic behaviors which challenge categorization within known natural entities. 8. An apparent origin in the region associated with the famous WOW signaling, unsettling coincidence for those rejecting unorthodox explanations. 9. A sudden increase in brightness accompanied by a distinctive bluish tint, surpassing the reference star utilized in observations. 10. Jets necessitating a solar absorption, area significantly larger than the nucleus size predicts, revealing a profound energy imbalance. 11. Acceleration suggesting a loss of about 13% of its mass, without a visible cloud to support such mass ejection. 12. Surprisingly, stable columnated jets that persist over millions of kilometers, devoid of distortions typically expected from an irregular rotating nucleus. To summarize succinctly, the scientific evidence currently available presents a compelling argument that Atlas is not a comet in the traditional sense. The amalgamation of X-ray emissions, anomalous metallic composition, forward and tail, non-gravitational acceleration, and discernible morphological patterns diverges from conventional comet models. This revelation doesn't settle everything, far from it, but science does not rely on absolute certainty. It demands alignment between theory and observation. Presently, this alignment favors a reassessment of Atlas's nature and the exploration of alternative hypotheses, including the potential presence of non-volatile materials and ejected structures with a technological function. The optimal course of action now is scientific and judicious. Observe, measure, and test against predictions. The mini-probe hypothesis lays out clear predictions for future orbital encounters. If observations substantiate these predictions, we may achieve a significant advancement in understanding. What are your thoughts on this evidence? Do the readings I provided seem convincing enough to regard Atlas as something more than a comet? Share your theories in the comments. Pass along the video, and if you haven't subscribed yet, please do. Comment and share to sustain this investigation. Let's keep an eye on the upcoming JUICE data releases and Hubble analyses, because the Atlas story is just beginning, and forthcoming observations may definitively establish that Atlas is not a comet.